Hello everyone, this is Patrick Laban. This is my final project for University of Washington's Embedded and Real-Time Operating Systems certificate program. I've developed a moisture sensor using the Nucleo Discovery Board using a Cortex M4 and a moisture sensor from SparkFun. We're also using the QP framework to run our RTOS and state design, which I'll show you in a few minutes. So you can see here we have the Nucleo board hooked up both to our moisture sensor, and we also have the same leads leading out to our voltmeter so we can see the direct amounts from that. So reading very small amounts right now, 0.46 millivolts. If we move this over from this extremely dry soil, in fact that might drop to zero, pretty much anyway. But if we put that in our moist soil, you see it's around 4 volts, and now I'm going to show you our results on the screen. Bear with me for just a moment. So what's happening is this thing's on a timer, and every 10 seconds it's running. So you might be able to see it here. Let me just reset it so you can see it a little bit better. So every 10 seconds it's taking this reading. Right now it should probably print out 4095. That's the value I seem to be getting anytime it's hot. Yeah, there we go. So I'm going to go ahead and move it from the moist soil back into the dry soil. And you can see it's dropped down to 64, so a very low amount. I'm going to take it completely out of the soil. It probably reads 0. Not 0, but 42, still lower. The other thing I've done is, instead of running off of the timer, you can also use the user button, and it will cause a manual test. I put it back into the moist soil, as you can see. Alright, so let me adjust and show you my state charts real quick. So this is my moisture sensor state chart. I'll just move in a little bit here so you can get a better picture. I'll try and get a better view of this possibly just on a manual edit. But anyway, so what is happening? So we enter our root state. We're configuring our analog digital converter, and then we are transitioning into our stop state. Upon entering that, we are starting a timer. If that timer either triggers or the moisture sensor start request comes over from the user button, I'll show you that in a minute. We're going to transition into the started. At that point on the entry, we're going to read our ADC value and print that out over to the UART terminal, which you have already seen. And then we're going to send, after that, we're going to send a stop request. That stop request is going to transition back into the stop state, upon which the start timer will restart. A specific interesting thing is, if you use the user button, you have to disarm the timer first before making the transition. Here's the user button. So this is the same from prior projects. From the only main change here is, instead of using the hold timer or any of that, all I've done is I've taken all of that out, and we are specifically just sending a moisture sensor start request upon button down. That's about it. Thank you for your time.